Good morning, happy Thursday. Today we're going to learn all about fronts, air masses, and essentially moving air. So we'll need our textbook pages 118 through 120, and then we're going to be completing workbook page 84. Before we go over the main concepts, let's go ahead and do some reading. So if you want to read alone, just pause the video and then skip a few minutes. Otherwise, let's go ahead and read. Moving air. You are surrounded by air that is usually moving. Moving air is called wind. Sometimes wind moves so slowly that the air seems perfectly still. Other times, it blows violently and destroys everything in its path. We can use and enjoy wind in many ways. A light breeze may cool us off after a ball game. A stronger wind may allow us to fly a kite high in the air. In times past, great winds pushed the ships of explorers across the oceans. Today, some people exercise dominion by using wind to help produce electricity. Air temperature. Although the heat from the sun comes through the atmosphere, the sun does not warm the air much. Instead, the sun warms the Earth's surface, which then warms the air above it. Air temperature is a result of the heating and cooling of the Earth's surface. The curved surface of the Earth affects temperatures. Sunlight hits some places from overhead and other places at a slant. The places that receive overhead sunlight are warmer than those that receive sunlight at a slant. Also, the part of the Earth facing the sun receives heat and is warmer than the part facing away from the sun. So we know this as the Earth rotates. This part of the Earth that's closer to the sun, that's when it's warmer, obviously, and then when it turns away from it, it gets colder. Since the Earth's surface does not heat evenly, the air in the atmosphere does not heat evenly either. This is why days are usually warmer than nights. So explain to me, why are days usually warmer than nighttime? Yep, because the air in the atmosphere does not heat evenly. Depends on the movement and the position of the Earth and sun. Air masses. A large body of air that has about the same temperature and moisture is called an air mass. Okay? An air mass gains its characteristics as it moves over the Earth's surface. For example, an air mass over cool land or water becomes cooler, and an air mass over an ocean will also collect moisture. As an air mass moves over a hot desert, it becomes warmer and drier. Air masses also vary in density and air pressure. The gas particles in cool air are close together, causing cool air masses to be denser than warm ones. And this is why cool air often has greater pressure. The zone of highest pressure in a cool air mass is called a high pressure center, represented by a capital H on a weather map. Because a cool air cannot hold as much moisture as warm air, cool air masses usually have cool, dry air. A cool air mass is cooler than the land under it. Over several days, the warm surface of the Earth heats the air mass, and warming allows the air to hold more moisture and causes the gas particles to spread out. As the air becomes less dense, the air pressure of the warmer air mass becomes lower. The area of lowest pressure in a warm air mass is a low pressure center, shown by a capital L on a weather map. Fronts. When two unlike air masses meet, so different, the boundary between the masses is called a front. A cool air mass may push itself under a weaker warm air mass, and this type of front is called a cold front, as you can see in this demonstration. The cold air mass over here is pushing under the weaker warm air mass. It often brings stormy weather that may include thunderstorms and hail. A cold front usually moves quickly through an area. After the cold front passes, the weather is usually cooler and drier than before. A warm front occurs when a warm air mass moves over a slower cool mass. So the warm air mass is going over the colder one. A warm front moves slowly and can take several days to leave an area. As a result, a warm front often brings several days of light rain or foggy weather. When a warm front passes, the following days may have warm, moist weather. That's why after a thunderstorm or after rain, you can feel the next couple days are a little moist, humid when you go outside, right? Sometimes air masses push against each other but do not move. And when this happens, the boundary is called a stationary front, as depicted in this picture. A stationary front may stay in the same place for several days. It usually causes cloudy skies and rainy conditions. So we got 3 different types of fronts. The cold front, it moves usually quickly. And when it leaves a cooler, drier weather. Okay? And it can bring thunderstorms and hail. Second, the warm front moves slowly, and it usually brings light rain or foggy weather. It becomes kind of foggy. You can't really see it. And then after it goes, the following days will have warmer weather. And then lastly, the stationary front is when the air masses push against each other, but they don't actually move, right? And this usually stays in the same place for several days, and it causes cloudy skies and rainy conditions. So the fronts basically affect weather conditions is what the summary is. So what the major takeaway is. So let's kind of go over the major points again. So first of all, wind is moving air, right? We all know this. And we read about how air temperature works. So the temperature of the air is affected or is a result of the heating and the cooling of the Earth's surface. And the sunlight will warm the Earth's surface, and then the Earth's surface will warm the air. Okay. And we talked about why days are usually warmer than nights, because Earth's curved surface affects the amount of sunlight that Earth receives. So we kind of talked about that. So the rotation also affects that, whether it's facing directly the sunlight or if it's turning away. And then air masses was a little complicated to understand, it might have been. However, it's basically just a huge body of air with the same temperature and moisture. If you guys have ever seen like the Weather Channel, you can see how they have different colors, right? The different colors represent the different types of air masses, and each air mass has similar characteristics and temperature. And high pressure centers and low pressure centers, they're depicted by, well, this one is H, and this one is capital L, and you can see these in weather maps as well. And H represents cool air mass, L represents warm air mass. In the fronts, we talked about the 3 types of fronts, but the definition is it's basically the boundary where 2 different air masses meet. So this here, that's a front. This here is also a front. And this here is a front. You can see that the warm and cold are meeting. And the place where they meet is called a front. So the cold front is when a cool air mass pushes itself under the warm one, and it will cause stormy weather, and the weather will become more chilly afterwards. Warm front is when the warm air goes over the cold, and it will cause light rain, foggy weather, and the weather will of course become warmer and moist after it leaves eventually. Stationary front, as you can see, is when the warm and cool air meet, but they do not move. They stay stationary, meaning that it will cause cloudy skies and rainy conditions. So this is all useful, especially useful if you're interested in becoming like a meteorologist or you're interested in studying weather conditions. Next thing I would like you guys to do is to watch this video, which I will add to the playlist as well as in the description box in Google Classroom. It's going to demonstrate the different air masses in the front. It's really interesting. This teacher, she's going to be using, demonstrations. So you can see the blue and the red representing the hotter one and the colder one. So take a moment to watch that and then come back to go over the workbook page. So again, it's page 84. Try to do it on your own first. So pause the video here, and then when you're ready, go over the answers with me. Okay, let's see what you got. Fill in the circle for each correct answer. An air mass over northern Minnesota becomes blank as it moves over the cool land area. So if an air mass goes over a cool area, is the air mass cool or warmer? If you look at page 119, it says, an air mass gains these characteristics as it moves over the Earth's surface. For example, an air mass over cool land becomes cooler, and an air mass moves over hot desert, then it becomes warmer. So that being said, we can say that if it's going over a cool land area like Minnesota, the air mass will be cooler. Number 2, as a cool air mass moves over a hot desert, then the cool mass will probably, what will happen to it? It will become warmer and drier because the desert is warm and dry. A high pressure air mass moves into a warm area. The air in the area, I can't talk today, will most likely blank. Okay, well, it tells you here, the zone of highest pressure in a cool air mass is called a high pressure center, represented by a capital H. Because cool air cannot hold as much moisture as warm air, cool air masses usually have cool, dry air. Alright, high pressure will most likely cause cooler air. Okay? High pressure centers are usually blank than low pressure centers. So do you guys remember that? So it says, warming allows the air to hold more moisture and causes the gas particles to spread out. As the air becomes less dense, the air pressure of the warmer air mass becomes lower. So lower pressure, less dense, right? So high pressure centers are more dense than the low pressure center. That's a confusing sentence, right? When a low pressure mass moves over land, it usually brings what type of air? Okay. It says it brings warmer air. Okay. Guys, we're doing good. I know this unit's kind of confusing, especially when we're doing it online, but just hang in there. Okay, now for fronts. This should be easier. When a warm air mass moves over a slower cool air mass, the boundary where the two air masses meet is called a blank. So when the warm goes over the cool, warm moving over the cool is called a warm front. Very good. All right. 7. When a cool air mass pushes itself under a weaker warm air, the boundary where the two air masses meet is called a blank. When a cool air pushes itself under warm. So if cool goes under the warm, cool air mass may push itself under a weaker warm mass. This is called a cold front. When two air masses push against each other and do not move, that's called a, very good, a stationary front. Okie dokie guys, that's it for science. Great job. I'll talk to you soon for reading. Bye.